Statements that follow logically from known undefined terms, definitions, and postulates are called theorems. The formal proof of a theorem has several parts. To understand how these parts are related, consider carefully the terms hypothesis and conclusion. The hypothesis of a statement describes the given situation, given, whereas the conclusion describes what you need to establish, prove. When a statement has the form, if H, then C, the hypothesis is H and the conclusion is C. Some theorems must be reworded to fit into the if, then, form so that the hypothesis and conclusion are easy to recognize. Give the hypothesis H and conclusion C for each of these statements. A. If two lines intersect, then the vertical angles formed are congruent. B. All right angles are congruent. C. Parallel lines do not intersect. D. Lines are perpendicular when they meet to form congruent adjacent angles. A. As given, if two lines intersect, then the vertical angles formed are congruent. Hypothesis: two lines intersect. Conclusion: the vertical angles formed are congruent. B. Reworded: if two angles are right angles, then these angles are congruent. Hypothesis: two angles are right angles. Conclusion: the angles are congruent. C. Reworded: if two lines are parallel, then these lines do not intersect. Hypothesis: two lines are parallel. Conclusion: the lines do not intersect. D. Reordered: when, or if, two lines meet to form congruent adjacent angles, these lines are perpendicular. Hypothesis: two lines meet to form congruent adjacent angles. Conclusion: the lines are perpendicular. The 5 necessary parts of a formal proof are listed in the accompanying box in the order in which they should be developed. Essential parts of the formal proof of a theorem. Number 1. Statement. States the theorem to be proved. Number 2. Drawing. Represents the hypothesis of the theorem. Number 3. Given. Describes the drawing according to the information found in the hypothesis of the theorem. Number 4. Prove. Describes the drawing according to the claim made in the conclusion of the theorem. Number 5. Proof. Orders a list of claims, statements, and justifications, reasons, beginning with the given and ending with the prove. There must be a logical flow in this proof. The most difficult aspect of a formal proof is the thinking process that must take place between parts 4 and 5. This game plan or analysis involves deducing and ordering conclusions based on the given situation. One must be somewhat like a lawyer, selecting the claims that help prove the case while discarding those that are unnecessary. In the process of ordering the statements, it may be beneficial to think in reverse order, like so. The proved statement would be true if what else were true. The final proof must be arranged in an order that allows one to reason from an earlier statement to a later claim by using deduction, perhaps several times. H. Hypothesis. Statement of proof. P. Principle. Reason of proof. Therefore, C. Conclusion. Next statement in proof. Theorem 1.6.1. If two lines are perpendicular, then they meet to form right angles. Write the parts of the formal proof of Theorem 1.6.1. Solution. Number 1. State the theorem. If two lines are perpendicular, then they meet to form right angles. Number 2. The hypothesis is H. Two lines are perpendicular. Make a drawing to fit this description. See Figure 1.65. Write the given statement, using the drawing and based on the hypothesis H. Two lines are perpendicular. Given, line AB is perpendicular to line CD, intersecting at point E. Number 4. Write the proof statement, using the drawing and based on the conclusion C. They meet to form right angles. Prove. Angle AEC is a right angle. Number 5. Construct the proof. Proof. Statements. Reasons. Number 1. Line AB is perpendicular to line CD, intersecting at point E. Number 1. Given. Number 2. Angle AEC is congruent to angle CEB. Number 2. Perpendicular lines meet to form congruent adjacent angles. Definition. Number 3. The measure of angle AEC is equal to the measure of angle CEB. Number 3. If two angles are congruent, their measures are equal. Number 4. Angle AEB is a straight angle, and measure of angle AEB equals 180 degrees. Number 4. Measure of a straight angle equals 180 degrees. Number 5. Measure of angle AEC plus the measure of angle CEB equals the measure of angle AEB. Number 5. Angle addition postulate. Number 6. Measure of angle AEC plus the measure of angle CEB equals 180 degrees. Number 6. Substitution. Number 7. Measure of angle AEC plus the measure of angle AEC equals 180 degrees, or 2 times the measure of angle AEC equals 180 degrees. Number 7. Substitution. Number 8. Measure of angle AEC equals 90 degrees. Number 8. Division property of equality. Number 9. Angle AEC is a right angle. Number 9. If the measure of an angle is 90 degrees, then the angle is a right angle. The converse of the statement, if P, then Q, is if Q, then P. That is, the converse of a given statement interchanges its hypothesis and conclusion. Consider the following. Statement. If a person lives in London, then that person lives in England. Converse. If a person lives in England, then that person lives in London. In this case, the given statement is true, whereas its converse is false. Sometimes the converse of a true statement is also true. The proof of a theorem is not unique. For instance, students' drawings need not match, even though the same relationship should be indicated. Certainly, different letters are likely to be chosen for the drawing that illustrates the hypothesis. Theorem 1.7.1. If two lines meet to form a right angle, then these lines are perpendicular. Give a formal proof for Theorem 1.7.1. If two lines meet to form a right angle, then these lines are perpendicular. Given line AB and line CD intersect at point E, so that angle AEC is a right angle. Figure 1.66. Prove line AB is perpendicular to line CD. Proof. Statements. Reasons. Number 1. Line AB and line CD intersect so that angle AEC is a right angle. Number 1. Given. Number 2. The measure of angle AEC equals 90 degrees. Number 2. If an angle is a right angle, its measure is 90 degrees. Number 3. Angle AEB is a straight angle, so the measure of angle AEB is 180 degrees. Number 3. If an angle is a straight angle, its measure is 180 degrees. Number 4. The measure of angle AEC plus the measure of angle CEB equals the measure of angle AEB. Number 4. Angle addition postulate. Number 5. 90 degrees plus the measure of angle CEB equals 180 degrees. Number 5. Substitution. Number 6. Measure of angle CEB equals 90 degrees. Number 6. Subtraction property of equality. Number 7. Measure of angle AEC equals the measure of angle CEB. Number 7. Substitution. Number 8. Angle AEC is congruent to angle CEB. Number 8. If two angles have equal measures, the angles are congruent. Number 9. Line AB is perpendicular to line CD. Number 9. If two lines form congruent adjacent angles, these lines are perpendicular. Theorem 1.7.2. If two angles are complementary to the same angle, or to congruent angles, then these angles are congruent. Theorem 1.7.3. If two angles are supplementary to the same angle, or to congruent angles, then these angles are congruent. Theorem 1.7.4. Any two right angles are congruent. Theorem 1.7.5. If the exterior sides of two adjacent acute angles form perpendicular rays, then these angles are complementary. Theorem 1.7.6. If the exterior sides of two adjacent angles form a straight line, then these angles are supplementary. Theorem 1.7.7. If two line segments are congruent, then their midpoints separate these segments into four congruent segments. Theorem 1.7.8. If two angles are congruent, then their bisectors separate these angles into four congruent angles.